Hello students, in a previous clip we have learned that magnetic field for the circular ring. Now we are just going to the one of the very important example which has been asked in AIMS 2013. You have been given such type of data. Let's say in front of you this is the figure and current is passing like in a such type of circular loop. So first of all you have been given very confusing part. I equals to 10 ampere, and again over here there is an arrow which is the only complicated part. So in this clip you can just see that your current is passing and you have been given such small points for your understanding, or you can say for the confusion. Your current is passing from this part is called as a 10 ampere, which is going inward, and again over here in the AB part our current is also passing, which is also holding the same value of a 10 ampere, and this one is perpendicular to it. So as per our Kirchhoff's law you will be confused that your current is passing, the same amount of current must be coming out, but this arrow indicating that current is going inside. So you might be confused, and that is why this example has been asked. But we are just following only simple few steps. B is equals to mu 0 I divided by 4 pi r into theta. This is the primary expression which we have discussed about, and we will discuss on this part only. Right now what I am doing is that simplifying this term. So B is equals to B, current and magnetic field is passing from the AB segment, B is passing from the BCD segment, and B is passing from the BDE segment. As our theory suggests us that whichever angle it is making, we will use that notation, but our current is passing from A to B, which is in the direction of our current. So our theta will be 0, so our magnetic field will be 0. So straight away this part will lead us to 0. Same is the course for the DE. This is the part which is making you confused because of the direction of the current, and you can see that it is also making that angle theta equals to 0. So this much part is 0. So we have only left part is that B, C and D. So I am putting that that is called as a BCD. My magnetic field is called as a BCD. Now I am using this part. So my value of B is equals to mu 0 I divided by 4 pi r, and my this much part is called as a pi by 2, and entire circle is a 2 pi. You are familiar with that. That would be only 3 pi by 2. Let's say we have in this term, in this example, given that our value of current is called as a 10 ampere, and let's say radius is called as 3 centimeter. Using this data I am using these values. So B is equals to, let's say, 4 pi cross 10 to the power minus 7, or my current is a 10 multiply by 3 pi, and this is called as a 4 pi. My value of radius is called as a 0.03, and this is called as a 2. So by solution I can have B is equals to 1.5 cross 10 to the minus 4 Tesla. Actually it is called as a 1.57 cross 10 to the power minus 4 Tesla. So you can see that only simple example, but it has been asked in AIMS 2013 with the only simple notation. We have a B is equals to mu 0 I upon 4 pi r into theta. We can solve this example. So there are another examples available to us. Let's say just think about it. So in this clip we will just now go to the another part. Let's say we have been given another example. Let's say current is passing in this much fashion. My current is passing like that, and it is having this much segments A, B, then C, and then D, and then this is the point O, and that radius R. So let's say I'm just giving you that data. I is equals to, let's say I'm just giving you 12 ampere, and radius equals to 2 centimeter. Now we have to solve this example with the only same type of theorem. We will just solve. First of all, you can just say that B is equals to, I have a B of AB, then I have a B of BC, then I have a B of CD. But you are aware that I have mentioned you previously my current is passing in this much direction. so that angle will be 0. This is also 0 angle, so my B will be 0 plus B of BC plus again 0. So I may have a B is equals to B of BC. So I am putting that mu 0 I divided by 4 pi into radius, and my angle for the such type of semicircle is called as a pi. So I may have my value is equals to mu 0 I divided by 4r. So I am putting these values. B is equals to 4 pi cross 10 to the power minus 7 multiply by 12, and that is called as my 4 and 0.02. So my magnetic field would be B is equals to 1.9 cross 10 to the power minus 4 Teslas. So only simple example you have in front of you, and its a solution is again a simple one. By only we have followed simple formula which is called as B is equals to mu 0 I upon 4 pi r into theta, and we have solved two examples with the help of that. In the next clip we will go and find it out two more examples.